Welcome back to The Explainer. Usually we kick things off with a neat little roadmap, but today we're jumping straight in. We are looking at Project Merkaba, and essentially we're deconstructing the future. This is a vehicle concept that completely blurs the line between science fiction and hard, peer-reviewed reality.
Seriously, imagine this for a second. What if your next car had absolutely no doors, a body made entirely out of hemp, and literally ran by harvesting energy from the ambient space around it? I mean, it sounds like a pitch for a sci-fi movie, right? But these mind-bending specifications are actually derived directly from grounded scientific research and advanced engineering.
Okay, let's dive into this. The source material refers to this concept as the car that photosynthesizes. And to really wrap your head around that, you kind of have to throw out your traditional idea of a machine. Project Merkaba isn't just a car. It's designed to act a lot more like a synthetic organism, an entity that actively harvests its environment to survive and move. Take a look at the sleek, seamless liquid metal profile of this 2+1 urban coupe design. Notice anything missing? Yeah, there are absolutely no panel gaps, there are no visible doors, no seams, no traditional joints whatsoever. It is a completely seamless one-piece hull. It's incredibly aerodynamic with a drag coefficient of just 0.13, but structurally, it requires a complete rethink of how a vehicle is actually put together.
That brings us to how this one-piece body architecture actually works. It relies on a design called a monocoque. Now, in a monocoque, the structural loads are supported entirely through the object's external skin. Think of it kind of like an eggshell. But while traditional cars might use heavy metals or complex assemblies of carbon fiber, this specific monocoque is manufactured in a radically different, super environmentally conscious way.
The researchers propose a carbon-negative hemp bioepoxide construction. This completely replaces traditional chassis manufacturing. Basically, by swapping out heavy glass fibers, which have a density of 2.5 grams per cubic centimeter, with hemp fibers sitting at just 1.5 grams per cubic centimeter, you drastically cut down the physical mass of the hull. And because hemp naturally captures so much carbon as it grows, this whole manufacturing process actually achieves a carbon-negative footprint.
And this brilliantly illustrates a major point in automotive engineering. Recent studies from our sources show that by utilizing these lightweight technologies and advanced conductive fibers, vehicles could become up to 35% lighter. When you slash the weight of a car by 35%, you subsequently reduce its energy consumption by an impressive 12 to 20%. And you do all of that without sacrificing an ounce of safety. It's a massive leap forward.
Okay, but a lightweight, seamless shell brings up a very practical, sci-fi level question. If it's literally one continuous piece of material, how on earth do you get into a car with no doors?
Well, this is where the engineering gets wildly fascinating. Opening the seamless hull works like this. The car's battery power sends targeted electric currents through microfluidic channels embedded in the hull. This current hits a magnetic field and creates what are known as Lorentz forces. The liquid metal network literally responds to this by physically morphing the completely flat surface. It continuously folds into a complex 3D shape-shifting a quote-unquote door to let you in, and then smoothly melting right back into that seamless shell once you're inside. Absolutely incredible.
And that morphing skin? It does way more than just open and close. By integrating photoluminescent films with the car's thermal systems, it actively manages its own temperature using UV light to reduce solar heating. But here is the craziest part. Depending directly on the battery power output and current energy state, these films react by changing the vehicle's actual color. The car will produce these incredibly vivid colors that illuminate and make it glow in the dark at night, all tied to how much juice is in the battery.
Now, what's really interesting here is how all this space-age technology translates to the actual road. Let's look at Merkaba versus the Tesla Model 3 efficiency. When you combine that ultra-lightweight one-piece hemp monocoque with the aerodynamic design, the numbers are just staggering. Project Merkaba requires only 88 watt-hours per kilometer. Compare that to the current market heavyweight, the Tesla Model 3, sitting at 133 watt-hours per kilometer. The Merkaba absolutely crushes the Tesla in sheer energy efficiency.
But it doesn't just use less energy, it actively gathers more of it. Thanks to a seamless perovskite solar skin operating at a remarkable 38% efficiency, just look at this solar daily range. The Merkaba pulls in 65 kilometers of free driving range every single day just by sitting outside in the sun. That easily beats out competitors like the Aptera at 40 kilometers or the Lightyear at 20.
Now, peeling back the layers, this technical cutaway shows the 13-node tensegrity chassis inside that seamless hull. But get this, it isn't just a structural frame, it is a toroidal energy topology. The entire vehicle acts as one massive, continuous ambient energy harvester, pulling power from multiple sources in its environment all at the same time.
Breaking down these 13 nodes of energy harvesting, the sun is obviously the heavy hitter here, pulling in a peak output of 1,200 watts through a photonic mesh. But it doesn't stop there. It uses Tribo Aerotech to capture about 50 watts from the wind. It has thermoelectric harvesters grabbing 30 watts from ambient heat. It even utilizes geomagnetic harvesting to pull power straight from the Earth's magnetic fields. It is literally feeding off the ambient energy of the planet.
So, the crucial point is, what does it actually do with all that collected energy? Deep inside the Merkaba is a 45 kilowatt-hour solid-state lithium metal battery. Because the car is so incredibly efficient and constantly harvesting power, it generates way more energy than you'd need for typical daily driving. That brings us to the net positive promise, vehicle-to-grid or V2G capability. With an 11 kilowatt output, it basically turns the car into a mobile, small-scale grid battery. You can plug it in to power your entire home during an outage or automatically backfeed electricity to the grid during peak pricing hours to actually earn yourself some money.
Think about it. We've got shape-shifting liquid metal doors, a crazy lightweight one-piece body made of hemp, and a machine that feeds off the sun, wind, and magnetic fields just to power your house. It leaves us with this final, profound question. Is the future of transportation a vehicle that gives back more than it takes? It is a mind-blowing, yet scientifically grounded vision of mobility that completely redefines what a car can be. Thanks for joining me on this explainer, and I hope it leaves you as fascinated by the future of engineering as I am.